Hey guys, we are going to do independent and dependent events guided notes. Okay, so let's start with the first one, which is blank is the chance that some event can occur. So hopefully we know this one. We've already done this, which is probability. Probability is the chance that some event can occur. This is the word that I want you to remember when you think about probability. When one event does not affect the outcome of another event, the events are called independent events. So guys, whenever we are doing more than one thing, so on yesterday's lesson, when we flip a coin and roll the number cube, those do not affect one another. Those are called independent events. So here are some key words that tell you that these are independent. So that would be like a coin. I can keep flipping a coin over and over and over and keep getting heads because that heads does not disappear. I flip it, I get a heads. Flip it again, I can still get a heads. Flip it again, I can still get a heads. Okay? Those are independent. A number cube. That is independent. A spinner. Okay? Here's an example down here. I can spin this spinner. If it lands on an A, the next time I spin it, I can still get an A. This A does not magically go away. Okay, I can still spin it. I still have that same chance. Okay? And then if you see the words with replacement or replace, okay? I know these are not words that we generally use just in our everyday speak, but it just means you are replacing it, okay? Make sure you have these written. These are kind of keywords to let you know that we are looking at independent events. The first one does not affect the second one. So when I look here, it says one letter tile is selected, and then the spinner is spun. Guys, we are doing two things here. Selecting a letter, spinning the spinner. So I have two events. Okay? What is the probability that both will be a vowel? Okay? So basically, guys, I want probability of a vowel. And then I want probability of a vowel. I do this one, then I do this one. Okay? So this is event 1 because it's a letter tile. Okay, I want a vowel. So look here. Remember vowels? A, E, I, O, U. Vowel. Otherwise, we have consonants, which are the other letters. Don't let them get you confused with the Y. They will always let you know if they want it to be that Y. Okay? So we're going to do the simple probability. Do not look at these together. These are completely separate. Okay? So right here, first of all, what I want you to know is that the denominator is 4 because that is the total. There are 4 tiles. Okay? I want a vowel. How many are vowels? A, E, nope, those are both consonants. So I have 2 vowels out of 4, okay? Now, I want to go on and simplify this. I can do this at a different time, but I want to do it now. I can tell this will simplify because these are both even, so 1/2, okay? Event 2, I need another vowel, so I have A, E, I, O, U, nope, and nope. These are consonants, okay? Not to be confused with continents, consonants, okay? So usually they use vowel because most students are more familiar with that. So how many outcomes are there total on this spinner? Hopefully you know there's 3. How many are vowels? We circled 1 of them, Okay, so 1/3. Now, guys, E1, E2, and we multiply. Now, if I was to draw this out into a tree diagram, which you are welcome to do, you are going to see that 2 answers out of 12, which is 1/6, is my answer. 1/3 times 1/2. I did this backwards, but it doesn't matter because it's commutative. 1/6. Feel free, though. You can make a tree diagram if you want. Okay, I'm not giving myself enough room, but if you make yourself enough room, you can do a tree diagram. You can already tell 3, 6, 9, 12. Okay, there'll be 12 outcomes. And these two will be vowel, vowel down here. Okay, so there'll be this one, vowel, vowel, and this one, vowel, vowel. Okay, so it'd be 2 out of 12. Trust me, try it if you don't believe me. Okay, 2 out of 12, which simplifies to 1/6. Okay, now, here is where we get a little more tricky. If the outcome of one event affects the outcome of another event, the events are called dependent events. It does affect. Somehow it's changing the total, okay? An example would be when you do not replace, or if you take 2 at the same time, okay? So it affects total on the second draw or whatever. Okay, so on this one it says, there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Determine the probability that 2 apples are chosen. Okay, so that means Ignacio selects an apple, and then Terrence selects an apple. Do we follow that? We're doing 2 things. Ignacio selects and Terrence selects. I have 2 verbs there. Okay? So, here's what we do. It doesn't say anything about replacement, so what I'm assuming is Ignacio gets a piece of fruit to eat, and if he eats that, he's not putting it back. So, here's my little sample space. I want you to think about this. Okay? Orange, 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 banana, 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 and apple, 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 apple. Okay? Since I'm doing 2 things, I am going to do E1, E2. Event 1 is I want an apple. Event 2 is I want an apple. Okay? So remember, when we're doing this, we need a total. So we're starting with Ignacio. Ignacio selects a piece of fruit at random. So what is the probability that he will choose an apple? Okay. So again, we're going to pretend that we obviously, these are maybe individual bags, whatever. We can't feel them because we can tell the difference between an orange, a banana, and an apple. So we'll just pretend that these are like selected ahead of time, like maybe in a paper sack where we can't see what's in them. So we need a total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm seeing a total of 16, or 4 plus 7 plus 5. Okay? So 16. How many are an apple? 1, 2, 3, 4, 5. Okay? So there's 5 apples. He has 5 chances. How many apples is Ignacio selecting? He's selecting, it says he selects a piece of fruit. He's selecting 1. Now we are assuming for this that he gets an apple. The chance of him getting it, he has 5 chances to get it. Okay? Now, this is why this one's dependent, because when Terrence reaches back in here, how many total pieces of fruit are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 because now there's not 5, there is 4. 15 pieces of fruit. How many are apples? 1, 2, 3, 4. Okay. Now what I will tell you is neither one of these will simplify. Okay. E1, E2, multiply. E1, E2, multiply. Here's E1. Here's E2. None of these would simplify. However, when you look at these, hopefully you see the relationship. Okay. Look right there. What will those both divide by? 5, right? 5 divided by 5? 15 divided by 5. Okay. Now I see another relationship here. What will these both divide by? You might have said 2, but we could also do 4, right? 4 divided by 4, 16 divided by 4, which is 1. 1 times 1, 4 times 3, 12. E1, E2, multiply. And this is my final answer. So one thing that lets you know that we have a dependent event is your total is going to change. It will always change by 1. It's going to go down 1 because we're only selecting one at a time. Okay?